Okay, so let me go back to the PowerPoint. So if you have had me before in General Chemistry 1 or in Introductory Chemistry, you would have heard me talk about this organization I'm highlighting right here. Whoops. Well, I'm not highlighting, I'm pointing. The International Union of Pure and Applied Chemistry, right? So this is an organization which, as the name suggests or states, it's an international organization. And this organization is, well, there's a division of the organization which is responsible for naming organic compounds and naming all compounds. But of course, there's a special set of rules for naming organic compounds. So we're going to follow the rules as outlined by this organization. And basically, when it comes to organic compounds, there are four parts. You have the parent part of the name, then the prefix, the locant, and then the suffix, right? And below here, they explain basically what each of these mean. The parent name identifies the main part of the molecule and tells how many carbon atoms are in that part. The prefixes identify the various substituent groups attached to the parent. The locants give the positions of the attached substituents, and the suffix identifies the primary functional group attached to the parent, right? So basically, every organic molecule that you'll encounter when it comes to the naming according to the IUPAC rules, International Union of Pure and Applied Chemists, basically these are the things that you'll be able to identify based on the name. So basically, again, this is one of those situations where if you're given the name, you should be able to draw the structure of the molecule, or vice versa. If you're given the molecular structure, then you should be able to determine the name of the compound, all right? So let me remind you, before I go into the actual rules for naming alkanes, if you remember I said that when it comes to the normal alkanes, based on the formulas, let me just do this here. Come on. Okay, so remember I said that the general formula for alkane is CnH2n plus 2. And if n is equal to 1, then the formula is CH4. And the name of this compound is methane. If n is equal to 2, then the general formula is C2H6. And the general name is N. And then you have n equals 3. The general formula would be C3H8. And the name would be propane. If n is equal to 4, C4H10 would be the general formula. And the general name would be butane. And if you remember, I said that when it comes to butane and other alkanes, higher alkanes, you can have situations where you have different formulas or different structures fitting the same formula. This should be 2 here, CH3, and this would be CH3, CH3, and CH3 here, right? These are two different compounds which will have the same formula. So these are isomers. We talked about that earlier, right? Isomers are different compounds having the same molecular formula. And then if n is equal to 5, H12, would be the general formula, and the general name would be pentane. And again, you can have more than one structure fitting that formula. If n is equal to 6, the formula would be C6H14, and this would be hexane. And n equals 7, C7H16, and that would be heptane. N equals 8, C8H18, and the general name would be octane. N equals 9, C9H20, and the general name would be nonane. And then let me just continue over here. When n is equal to 10, the formula becomes C10H22, and the general name here would be decane. All right. Now, you need to remember these names in order for us to move into what I'm about to discuss shortly in terms of naming alkanes, because what you're going to see, of course, is that not only do we have alkanes that would fit these names, but you can have other alkanes where you have different structures, which has actually more than 10 carbons, right? However, we won't go beyond 10 carbons in terms of the general names, but you're going to see some structures which has more than 10 carbons and may have some branching and so on. And that's where the rules come in, right? I want to remind you also, this is something I mentioned before, that between each of these compounds, the difference would be CH2, right? So basically to get from one to the next in terms of the general formula, you just add a CH2 unit to it and you get the next formula, all right? Okay, so with that said, let me go back to the PowerPoint and let me talk about how do we go about naming alkanes. All right, so these are the rules I'm about to get into, and I'm going to go into some actual examples so that you can follow the rules. I think the best way to learn the rules is to apply them to different situations. So the first rule says you find the longest continuous chain of carbon atoms in the molecule and use the name of that chain as a parent name. Remember, one part of the name of the alkane is a parent name. So this rule is helping you to determine or derive the parent name for the alkane, right? Now, one key thing you need to keep in mind is noted right here. It says that the longest chain may not always be apparent from the manner of writing. You may have to turn corners in inverted quote marks. So basically, this rule is saying that you need to identify the longest chain, and the longest chain may not be the obvious one based on how the structure is drawn. So another point here about this rule is that if two different chains of equal lengths are present, choose the one with the larger number of branch points as a parent. And I think we're going to see maybe one or two examples of that. In fact, let me get out of this here and let me go to my writing application here. And let me get rid of this here. And let me start off with the first example, which is CH3, CH2, CH2, CH, and then we have CH2, CH3, and then we have CH3, all right? So let's say you're asked to name this compound. The first rule says you need to find the longest chain of, wait, give me 1 minute here. Oh, I'm sorry. You're the only one in class right now. In person, the rest is on Zoom. Okay. Okay, so according to the first rule, for young lady who just walked in, I'm just going to briefly explain what I'm doing here. Basically, what I'll be doing is teaching you guys how to name alkanes according to the International Union of Pure and Applied Chemistry rules, right? So we just started the first rule, right? So let me just quickly say what the first rule is. When it comes to naming alkanes, you need to find the longest continuous chain of carbon atoms in a molecule and use the name of that chain as a parent name. The longest chain may not always be apparent from the manner of writing. You may have to turn corners. And then it says if you have two different chains of equal length are present, choose the one with the greater number of branch points. In other words, the ones with the greater number of substituents, all right? Okay, so I was about to get into one example. And the example is this right here. So let's find the longest chain. Now, you might be tempted, and to be perfectly frank, I wouldn't blame you. You might be tempted to think that this is the longest chain of carbon atoms that you can identify in a molecule. But that would not be correct, right? Because in actual fact, let me erase this here. Okay. In fact, the longest chain, CH3, would be this right here. All right? So that's the point of the rule that I'm just mentioned. The longest chain may not be the one that is the most obvious. You might have to do some twists and turns to establish the longest chain. So in this particular case, The longest chain contains 1, 2, 3, 4, 5, 6 carbon, which means that the parent name is hexane. So let me write here, parent name. And this will be part of the name of the entire molecule that we can derive later on. But for now, it is important that you're able to identify the parent name. Let me give another example. Let's say you're given CH3, CH, CH2, CH3, and then here you have CH, then you have CH2, CH3, and then down here you have CH2, CH2, CH3. So the question again is, which is the longest chain that you can identify in this molecule, all right? And again, you might be tempted to think that this is the longest chain right here, but that's not the case. The longest chain is actually this right here I'm drawing around, right? That's the longest chain because the first chain that I circled has 1, 2, 3, 4, 5 carbons, but this chain that I have more recently circled has 1, 2, 3, 4, 5, 6, 7. So in this particular case, the parent name is heptane. All right. So that's basically how we identify the parent name, which is basically what the first rule is all about. Okay, any questions about this? Any questions? Including you guys out there in Zoom. Any questions about identifying the parent name? Okay, so I take it that you understand that. So let's move on to the next rule. The next rule says, beginning at the end nearer to the first branch point, number each carbon atom in the parent name, or the parent chain, I should say. All right. So let me see here. Okay, so let's go back to the examples that I had before. Let me go get out of this here. Go back to this here. Okay, so let's go back to this right here. So basically, what the next rule says is that you number the carbon atoms of the parent chain, but you have to start at the end, which is closest to the nearest branch. All right. So we already identify, hold on 1 minute. We already identified the parent chain in the first example, which is this chain right here, which is circled, right? So the question now becomes, based on the second rule, from which end do you start numbering from? Do you start numbering from this end or this end? And the answer is this end, because this end is closest to this branch, right? This is the branch hanging from the longest chain, right? So we start numbering 1, 2, 3, 4, 5, 6, okay? That's the longest chain that we have numbered. We start numbering from here, and then we continue to the end of the chain. We start numbering from here because this branch here is closest to this end compared to this end, all right? In the case of the second chain, again, the question now becomes basically which end you're going to start counting from. We have already identified the longest chain, which is this chain right here. And the answer is basically we're going to start numbering from this end, right? And not this end. And the reason why is because this branch here is closest to this end here compared to this branch, which is 1, 2, 3, 4 carbon removes. This one is 1, 2, 3 carbon removed from that branch. So therefore, we start numbering here. 1, 2, 3, 4, 5, 6, 7. All right. So that's basically how we deal with the numbering system, which will become important in terms of obtaining the final name of this compound. All right. Any questions about the numbering system? Any questions? Any questions out there in Zoom? Okay. So the next rule, number 3, let me blow this up here. It says assign a number to each substituent to locate its point of attachment to the parent chain. if there are two substituents on the same carbon, give both the same number, there may be as many in the name as there are substituents. Okay, so let me explain what that means. Going back to our examples here. So in this case, based on the numbering system that we have established, right, we'll notice that this group here is attached to carbon number 3, right? So now we have to indicate the name of this group, right? And the name of this group is called a methyl group, right? And I probably should have taught you guys how to identify the alkyl groups. All right? The alkyl groups are basically groups that have this formula, CnH2n plus 1, right? So if n is equal to 1, this becomes CH3, and that's called the methyl group. All right? And the methyl group, or I should say the alkyl groups, their names are derived by removing the ANE ending from the corresponding alkane and add YL, right? So methane becomes methyl, ethane becomes ethyl, propane becomes propyl, and so on and so forth, right? So we have the methyl group right here. Okay. So the position of the methyl group is that it's bonded to carbon number 3. So I'm going to put 3-methyl here to indicate the position of the methyl group, right? Now, in the case of this molecule here, we have 2 groups. We have this group here, and this has become a bit messy here, but try to follow. We have this group here, which is called the ethyl group because the formula becomes C2H5. If you look at this here, this is C2H5. This is, actually, hold on. Okay, I'm being confused because of the messiness of this. I misspoke. Let me erase this circle right here and rewrite. So this is CH3. This is CH2. All right. Okay. All right. So the mistake I made was that I isolated this group here, which I should not, because that's a part of the longest chain. So this is the longest chain that we have identified. There are 2 groups that are present. We have the methyl group here, and we have the ethyl group here. All right. So in terms of where these groups are located, we have the methyl group bonded to carbon number 3. So I'm going to put 3-methyl here. And we have the ethyl group bonded to carbon number 4. I'm going to put 4-ethyl. All right. Okay. So that's basically what is involved in identifying the location of the different groups that are branching from the main chain. Once we identify the main chain and we number the carbon atoms, then the next step is to identify the branches of that chain and indicate their location. In this particular case, the methyl group is bonded to carbon number 3, and the ethyl group is bonded to carbon number 4. All right. So let me go back to the PowerPoint again, and we're going to move on to the next rule, which says, use hyphens to separate the different prefixes and use commas to separate the numbers. If 2 or more different substituents are present, cite them in alphabetical order. If 2 or more identical substituents are present on the same chain, use one of the multiplier prefixes, di, tri, tetra, and so forth. But don't use these prefixes for alphabetizing. Full names for some of the examples we have been used. Oh, that's something that I mistakenly pasted and copied, which does not apply. Anyway, so let me explain now how we put everything together based on what we have done so far in order to name these compounds. So what I'm going to do here is go back to this right here. And in the interest of making things look a bit more neat, what I'm going to do is get rid of these. And I'm going to start with the first one again, which was CH3, which was CH3, CH2, CH2, CH, CH2, CH3. And then we have CH3 here, right? So as I said before, I identified this as the longest chain. right? And I numbered it starting from here. 1, 2, 3, 4, 5, 6. So remember I said that the parent name is hexane. And we have the methyl group here. Is bonded to carbon number 3. So I'm going to put 3-methyl here. So based on what I have so far, the name of this compound would be 3-methyl hexane. All right, so that's basically how that is named. All right, we have the parent name, which indicates the number of carbon atoms in the longest chain. We have identified one of the branches, which would be the methyl group, and that methyl group is bonded to carbon number 3. So therefore, that's why the name of this compound is 3-methyl hexane. The other example that I had before was CH3, CH, CH2, CH3, and then we continue here, CH, and then we have CH2, CH3, and then we have down here CH2, CH2, CH3. So as I recall, this is the longest chain. And we start numbering from here. I explained the reason why that is already. 1, 2, 3, 4, 5, 6, 7. So the parent name, parent name is, in this case, heptane. We have 2 branches here. We have the methyl and we have the ethyl here. This is the methyl. This is the ethyl. And the methyl is bonded to carbon number 3. And the ethyl is bonded to carbon number 4. So I'm going to put 4-ethyl here. So when we put this together now this is going to be very important because in this case, we have 2 different substituents or 2 different branches. And this is the name of this compound when we put this together. 4-ethyl dash 3-methyl. And then heptane would be the final part of naming this compound. So this would be the full name of this compound. Now, you might be asking or thinking, why is it that the 4-ethyl comes before the 3-methyl, right? And the answer is, if you go back to the rules I mentioned before, we say that we indicate the groups alphabetically in order, right? Without any consideration of the number that represents their positions in the longest chain, all right? So alphabetically speaking, ethyl comes before methyl. So therefore, you have to indicate the ethyl first, then the methyl, even though the ethyl is indicated to be in the 4th position on the longest chain, while the methyl is in the 3rd position. So we don't go according to the numerical order of the substituents or the branching. We go according to the alphabetical order in terms of naming these compounds, all right? Okay. Any questions before I move on to one that's a bit more complicated? Any questions about this? Any questions? No questions? All right, so let me, I take it it's okay for me to eliminate this, clear this. Okay, so I'm going to make up, well, let me see if I can find an example in my papers here. Okay, here's one. So let's say you're given CH3, CH, and then up here I have CH2, CH3, and then CH2, CH2, and then CH, CH3, and then CH, CH2, CH3, and then CH2, CH3. Okay. So my question to you is this. How many carbons are in the longest chain? Let me see if you know how to identify the longest chain of carbon atoms in this case. And you guys out there in Zoom can chip in your responses as well. How many carbon atoms are in the longest chain in this molecule? Okay, somebody responded. Okay, somebody said 9. Who said 9? That would be Mr. Peterson. Okay. And Mr. Peterson, you're actually correct, right? So basically, what I'm about to circle would be the longest chain. Right here. And by the way, now that I notice it, I could have gone, let me show you one alternative, which would make a difference in this case. I could have gone this way in this particular case to establish the longest chain, right? I could have done this, and that would be the longest chain, because once you get here, you have this group here, which is the same thing as this group here. So it doesn't matter in this case if I went this direction or this direction. But what I'm going to do, just to make life a bit easier in terms of you guys understanding what's happening here, I'm going to say that the longest chain continues this way, like this. And that would be the longest chain, right? Okay, so now that we have established the longest chain, the question now becomes, in the next step, how do we number the longest chain, right? And if you recall, I said that in numbering the longest chain, you have to make sure that you start from the end that is closest to a branch. However, in this particular case, we have a situation here where if you start counting from here, 1, 2, 3, this methyl group will be on the third branch. If you start counting from here, 1, 2, 3, this ethyl group is on a third branch as well. So the question now becomes, which end do we really start from in this situation where you have a conflict, all right? And not only that, you have this methyl group here, which is on the fourth branch, but we'll get to that later on. So basically, according to the rules, right, we go alphabetically again. If you have that situation where we have one group, which is just as close to one end as the other group is to the other end, then we look at the names of those two groups. This is the methyl group, and this is the ethyl group, right? In this case here, therefore, the ethyl group, well, we go according to, the ethyl group having the lowest locator. So that's 3, 4, 5, 6, 7, and then we have to erase these 2, 8, 9, all right? So that's the numbering system that we're going to use starting from this end, ending up at this end right here. So that means that we're going to have the ethyl group at carbon number 3. So I'm going to put 3 ethyl here. And then we have 2 methyl groups. We have 1 methyl group here, 1 methyl group here. This methyl group is on carbon number 4. And this methyl group is bonded to carbon number 7, right? So we have to take those 2 methyl groups into account, all right? Another thing which was mentioned in the third rule is that if you have located more than one type of group in the molecule, then we have to use the prefixes that you should be familiar with from General Chemistry 1. Mono, well, we don't use mono in this case, but we do use di, tri, and so on. Di for 2, tri for 3, and so on. In this case here, we have 2 methyl groups. So therefore, we have to use the di prefix in front of the methyl group to indicate that there are 2 of them. So now we're going to put everything together. And first off, we're going to put, in terms of the total name of this molecule, we're going to start off with 3-ethyl, then followed by dash, then 4,7-dimethyl, and then the parent name, which would be nonane, because there are 9 carbon atoms in the longest chain. And this, ladies and gentlemen, will be the full name of this molecule: 3-ethyl, 4,7-dimethyl nonane. All right, nonane because there are 9 carbon atoms in the longest chain. All right. Okay, any questions about this particular example? Any questions? Any questions out there in Zoom? Okay, so let me see. No, let me modify this one a bit. Let's say, how should I do this now? All right, you know what? Let me not. I was about to get into something which maybe I should not get into. Let me just do another example. Let me clear this first. Let me clear this. And let me put up another example right here. So in this example, I have CH3 bonded to CH2, bonded to C, and then up here, I have a CH3 here. Down here, I have CH2, CH3, and then here, I have CH2, and then here, CH bonded to CH3, and then here, CH3. Okay. So let's say we have this molecule, and my question again is, how many carbons are in the longest chain? Let's start off with that first. Okay, somebody responded. Let's see who responded. Okay, so Mr. Peterson again answered correct. The answer is 6. So the 6 carbon atoms are, again, there are 2 possible ways, but I'm just going to go the one that's most obvious. I could have just as well exclude this and include these 2. Still end up with 6 carbons in the longest chain, right? Okay, now, so my question, the next question I have for you guys is, okay, so since we have identified the longest chain, from which end would you start numbering? From the left or the right? The right, why? Yep, okay, so basically, you're going to start numbering from here. 1, 2, 3, 4, 5, 6. And for those of you out there in Zoom, just in case you didn't hear what she said, because this end is closest to the nearest branch, which is this methyl group here, compared to this end, which is 1 carbon removed from the nearest branching carbon, which contains these 2 groups right here, right? So that's a numbering system that we're going to use. Okay, very good. So the next step is we have to identify the groups that are branching off the longest chain that we have identified and where they're located on the chain. So what 2 groups are located? Or what 3 groups are located? I'm sorry. Yeah, this is called an ethyl group. So we have an ethyl group bonded to carbon number 4. We have a methyl group bonded to the same carbon number 4. And we have a methyl group bonded to carbon number 2. All right? Okay, so now we put the names together. Identify the groups, we identify where they're located. Oh, we didn't have identify where they're located. So this is carbon, the methyl group is on 4, the ethyl group is on 4, and this methyl group is on, I'm sorry. And the methyl group here is on 2, right? Now, again, we have to go alphabetically, right? In terms of indicating where the branches are. So the first thing we're going to put here is 4-ethyl, right? Then we put a dash. And since we have 2 methyl groups, one is located in the second position or in the second carbon. The other one is located on the 4th carbon. And then we put dimethyl, right? Because there are 2 methyl groups. One bonded to carbon number 2 and the other bonded to carbon number 4, all right? Then we put the final part, which would be the parent name, which has 6 carbons, so therefore, the last thing we're going to put there is hexane, and that's it. So the full name of this compound is 4-ethyl 2,4-dimethyl hexane. All right? Okay, any questions about this particular example? Any questions? Okay, all right, there's some other rules that comes into play, which I won't get into because that's something that's a bit more complicated for this level. So I'm just going to leave that for you guys who plan to do organic chemistry to look up on your own. All right, so what I'm going to do is, let's do 2 more examples and then I'll get you started on the next assignment. So let me do this here. And let's say you're given CH3, CH, 2, CH, and then you have CH2, CH3, CH, CH3, CH2, CH, 2, C, CH3, CH3, CH3. And what I'm going to do is make a minor change here. CH2, CH3. Okay. So that's just something I just made up. I don't even know what the name is yet. So first step. So what's the first step, folks? Based on what we have done so far. What's the first step? Okay, so how many carbons are in the longest chain? Okay, let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9. You're absolutely correct. And that means that you know that this is the longest chain right here. All right. So the next question now becomes, from which end would you start numbering this chain? Would you start from here or here? The right side. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Very good. Next step. Okay, you have 2 methyl groups here and here. Anything else? A methyl group on 5, okay, and? Okay, very good. Okay, so now that we have identified the methyl and ethyl groups, the branches, I'm going to put here that the methyl group is, there are 2 methyl groups on carbon number 2. So that's why I have to put dimethyl. And you're going to see something about how we name this when it comes to 2 identical groups on the same carbon. And then we have another methyl group. In fact, let me do it here, actually. So basically, in the IUPAC system, what we need to do is indicate that there are 2 methyl groups on the same carbon. So we're going to put 2 and 2 here, right? We do that because both methyl groups are on the same carbon, right? Another thing that because there's another methyl group here, that will be on carbon number 5. So I'm going to put 5 here. And what I'm going to do as a result is erase this here and put tri, because that's what we need to do when it comes to indicating the correct number of a particular group, in this case, a methyl group. So therefore, you're going to see this as a part of the name of the molecule, 2,2,5-trimethyl, all right? We also have an ethyl group bonded to carbon number 6. So I'm going to put 6-ethyl here, all right? So the full name, oh, and by the way, the parent name, let me just put that here. The parent name is nonane, because there are 9 carbons in the longest chain, right? So when we put this together, the final name of this compound is, we have to indicate, again, alphabetically, the order of the branching. We're going to start off with 6-ethyl first. Whoops. Okay, why is this happening? Okay, I don't know what's going on here, folks. Let me try to straighten this out. Okay, I don't know what's going on here, but let me do it over here. So the full name of this compound would be 6-ethyl. What in the world? Oh, okay. So the full name of this compound would be 6-ethyl, then 2,2,5 trimethyl nonane. All right? So that's basically how we would do that particular naming of that particular structure. All right? Okay, any questions about this? Any questions? Any questions? Any questions out there in Zoom? No questions? All right. Let me clear this. And let's do one more example before we move on to the assignment question. So again, I'm just going to make up something here. So let's say you're given CH3, CH2, CH2, no, I'm sorry. Okay, let me continue here. CH2, CH3, CH2, CH3, CH2, CH2, CH with a CH3 here. This keeps happening and I don't know why. Okay, what was I saying? This would be a CH3, CH, two CH3. Okay, let's leave it at that. All right. So let me see if you guys can do this on your own without any help on my part. What's the name of this compound? Let me just ask you that straight off. What do you think the name of this compound is? Based on all that we have done so far. Oh, by the way, I made an error here. Hold on, let me correct it. There should be only one, no hydrogens here. And everything else is fine. Okay. Well, any ideas? Okay, somebody answered. Let's see. Oh, Mr. Peterson again. So you're saying the answer is 3,3-diethyl 6-methyl octane. 1, 2, 3, 4, 5, 6, 7, 8. Okay, yep. That would indeed be correct, Mr. Peterson. So let me explain why that is. He correctly identified the longest chain, of course, which is this right here. Again, there are some other possibilities in terms of the longest chain, but we'll go with the most obvious one. You could have just included these ethyl groups here and here in each case. And then the question now becomes, from which end do you start numbering from? Do you start from the right or the left? And the answer is you start from the left. And the reason why is because you have two branching from this carbon here, which is carbon number 3. In fact, let me number the carbon, well, yes, which will be carbon number 3, 1, 2, 3. If you start counting from that end, if you start to come from this end, there's only one branching. There's only one branching from, if you, what in the world? If you start counting from this end, then this is the methyl group that would be there, where it's on carbon number 3, but there's only one of them. So therefore, this would be the numbering system: 1, 2, 3, 4, 5, 6, 7, 8, right? So the parent name is octane, right? And you notice that you have 2 ethyl groups bonded to carbon number 3. So we indicate that by saying 3,3-diethyl. All right? And then now, the methyl group is bonded to carbon number 6. You put a dash, then 6, then dash again, and then methyl octane, and that completes the name of this particular molecule. All right. Any questions about this one? Any questions? Any questions? Okay, so let me, what time is it? Not sure. Oh, okay. We have less than 30 minutes. Okay, so let me see if did I publish? Let me see if I published this assignment. Assignment. Okay, so this will be assignment number 9. Okay, so I did publish it. Let me just download it here. So you guys out there in Zoom can access it right now. So the first part deals with giving you some structures for you to name. And then the second part is where you're given the names and you're asked to draw the structure, which is actually easier when you think of it. So let's get started on the first one, which is very easy. Everybody should be able to do this one based on what we have done today. So what's the name of the first one? Well, how many carbons are in the longest chain in the first one? 3, right? So what would be the parent name? Nope. Those are the 3 carbons, right? Can anybody out there in Zoom tell me what the parent name is? Propane. Thank you, Miss Miller. So propane is a parent name. And in this particular case, it doesn't matter which end we start counting from, because this branch would be on the same numbered carbon regardless. So 1, 2, 3. So therefore, what's the name of that group? Methyl. And to what carbon is the methyl attached to? Right, so the name of this molecule is 2-methyl propane. All right? Okay, what about the next one? How many carbons are in the longest chain? 4. Okay. And what's the parent name for a 4-carbon chain? Let's see if anybody out there in Zoom knows. Butane. Again, Miss Miller, thank you. Okay, so butane would be the parent name. Okay, and basically these would be the 4 carbon atoms in that longest chain, right? So the question now becomes, from which end would you start your numbering system? Would you start it from here or would you start it from here? And by the way, here's a branch here. Let me put that in squares. So that's a branch, right? So from which end would you start numbering from? From here or here? The top one or the bottom one? The top one, exactly. 1, 2, 3, 4, right? So basically, what's the name of this compound as a result of that? 2-methyl butane. Very good. All right. Let's look at the third one. So my question to you is, what's the parent name based on the longest chain of carbon atoms you can identify in this molecule? Okay, somebody answered. Let's see who answered it. Miss Miller again, heptane. So the parent name is heptane. Okay, so the next question is, from which end would you start counting your carbon atoms of the longest chain? Because obviously that means that this is the longest chain right here, right? So from which end would you start counting? Well, anybody on there in Zoom want to answer that question? Hmm? Nobody wants to answer this one, and this one is actually very easy. Exactly, it doesn't matter, right? Because it doesn't matter if you start counting from here or here, this carbon is going to be number 4 anyway, which has a branch, right? So I could do this, right? And based on that numbering system, this group, what's the name of this group? The C2H3, what's the name of that group? Right, so it's 4-ethyl heptane. That's the full name of that compound. All right, so I've done the first 3 with you guys. So you should be able to do the others. But of course, if you have any questions, feel free to ask while I'm here. In the meantime, I forgot to take roll at the beginning of class, so let me do that now. So let's see if I can bring up the names of the people here in Zoom. Okay, so Anderson is here. Chessmore is not here. Gonzalez, hold on, let me see here. Gonzalez Alba is not here. Hickey is not here. Hislop is not here. Jabbar is not here. Jones is not here. Labrador here. McKeon is here. Miller is here. Peterson is here. Papa is not here. Simpson is not here. And Welter is here. Okay, very good. Yes, ma'am. 1, 2, 3, 4, 5, 6.
Those are the branches are all methyl
Right.
groups. So, and each of them are 3 away from the ends.
Okay.
We start
All right. So
doing an alphabetical order, but you don't count the
Yeah.
cubics.
well, there's no alphabetical order because they're the same groups, right? But hold on, let me bring this up for the sake of your fellow students out there in Zoom. What's going on here? Okay, share screen. And then, okay, so, oh gosh, okay. Let me go here. I thought I had it here before, hold on. Okay. I guess I closed it accidentally. Wrong class. Okay, so which one you're talking about now? 1, 2, 3, 4, 5, 6. Okay, this one? Right, so in this case here, as you correctly said, you have 3 methyl groups hanging off the longest chain, right? So I guess you're wondering from which end you start counting? Okay, and the answer would be, or let me see if anybody out there in Zoom can tell me. For this one, this is the one that she's asking about. Obviously, in fact, let me do this. Obviously, oh shoot. The longest chain okay, so this is the longest chain right here. All right. So the question she's asking is, from which end would you start counting? From the left or the right? Okay, somebody answer. Let's see. From the left, indeed correct. Now, the reason for that, 1, 2, 3, 4, 5, 6, 7, right? The reason for that is because you have 2 methyl groups bonded to that carbon compared to one bonded to the other carbon from the other side, all right? So what do you think the name of this compound is? Anybody out there in Zoom want to take a stab at this one? Okay, somebody answered. Okay, so Miss Miller again answered, and she said 3,3,5-trimethylheptane, which is indeed correct. So the name is 3,3,5-trimethyl, and then heptane. All right. Now, I just realized something. You guys may have, or maybe you got it correct. for the one just before this one that we just did. So let me clear the drawings for this one. Okay, I want to hear what you guys got for this one. For this one right here. Five propyl. Okay, you said 3-methyl. Okay, 5-propyl. Oops, this pen is, I don't know what's going on with this here. 5-propyl octane, okay. All right, yeah, that's correct, okay. Just making sure that you guys are on the right track. Oh, today's the eclipse, right? I forgot to buy my glasses. Dang it. I wonder if Professor K has, and I can't even leave campus today because I have back-to-back classes. What time is the eclipse exactly? Let me check here. And I was planning on stopping at Walmart yesterday and completely forgot. Time of eclipse, solar eclipse. Let's see here. It will be visible across North America. It says New York at about 2:04 p.m. Hold on, my class. Yeah, my class starts at 2. Ah, I'll check it out online. But from what I've heard or read, we won't, I mean, we're too far down south to get the direct view. Okay, folks, it's 9:40 now, so I think I'm gonna stop here. So try to do the other questions and make sure you save it because I think I have to produce an addendum to this for some more problems for you guys to do. But try these, and if you have any questions, feel free to contact me so that you can get my help. Oh, and by the way, to remind you that the excuse me, test number 2, when is that due? Let me confirm that. Test number 2 is, oh shoot, hold on. Oh, it looks like I didn't publish the Oh, I have it due today, actually, but let me see here. But I didn't publish it, so what I'm gonna do is change the date on this here for tomorrow. Yeah. So let me do this here. And so tomorrow is the 9th. Okay, so the do-over will be due tomorrow at midnight, so make sure you complete it by then. Okay, so that's it for today, folks. I'll see you guys on Wednesday. Hmm.
I'm a senior right now in high school. I just need actual opinion. Do you think I can pass your class? Because I'm not doing well in your class right now. I will do the test remakes, but
Mhm.
I don't know how well I'm gonna.
Well, let me
do this.
see what your scores are.